Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 6, Lesson 5, Recognizing Structure to solve two-step equations. Now the entire time you've been solving equations, whether they were one-step or two-step, you've been recognizing the structure of the equation. You know, in a one-step equation, if you had something like x plus 3 is equal to 7, you recognize that what was happening to x, the structure, was that it had 3 added to it, so you had to subtract 3 to solve. Same thing with two-step equations that we've been seeing. Today we're going to look at some equations where you might think of using things like the distributive property or stuff like that, but where if we recognize structure of what's really going on in an expression or within an equation, we can use that structure to maybe make solving the equations a bit easier. So let's get right into that in exercise number 1. Here we go. All right, exercise number 1. Consider the equation 3 times the quantity n plus 2 equals 21. Letter A asks us to show that n equals 5 is a solution to this equation. All right, awesome. Why don't you go ahead and do that quickly in letter A. Never hurts to remind ourselves how to see whether or not a particular value is a solution to an equation. So I'm just going to substitute 5 in for n in that equation, right? We get 5 plus 2, which is 7. Then we do 3 times 7, which is 21. And it definitely is a solution. True equation means it's a solution. Now for letter B. List the steps in order that you use to evaluate the left-hand side at n equals 5. All right, so simple enough, right? Think about this. The first thing that we did, right, is that we added 2 to n. We added 2. Added 2. And the second thing we did is we multiplied by 3. Right? That's what we did. We added 2 and then we multiplied by 3. Now let's take a look at letter C. Solve the equation by reversing the steps from B in the opposite order. Right? Because that's the way that we have pretty much always solved equations. We've said, all right, well, what's going on in this structure? Well, we add 2 and then we multiply by 3. So to undo that, we should divide by 3 and then we should subtract 2. So let's go ahead and do that together. All right, let me bring this up. We had 3 times n plus 2 is equal to 21. All right, so the first thing I'm going to do is divide both sides by 3. All right, 3 divided by 3 is equal to 1. I don't need the parentheses anymore. I get n plus 2 is equal to 7. And now I subtract 2 from both sides, and I get that solution, which we knew from part A, n equals 5. Now, you might be saying to yourself, wait a second. In the last lesson, when we had equations like this, 3 times n plus 2 equals 21, but the first thing we did was we used the distributive property to write an equivalent expression on the left-hand side. Well, let's do that in letter D and see if we get the same answer. Let's take a look at letter D. Solve the equation by manipulating the left-hand side first using the distributive property. All right, so let's do this as well. Right? So in the last lesson, we said, well, sometimes we like to use properties of real numbers to, let's say, write an equivalent expression like this, and then solve this using kind of our classic two-step process. Right? So we subtract 6 from both sides. We get 3n equals 15. Divide both sides by 3. Toss our eMath Instruction logo out of there. And we still get n equals 5, right? 15 divided by 3 gives me 5. So that works as well, right? It works just fine. So why do we learn both approaches? Well, we learn both approaches to give you flexibility. Can you just distribute and simplify the left-hand side and solve the way we did in the last lesson? Sure. But in fact, you know, it maybe makes more sense to kind of look at this and say, well, you know, n had 2 added to it, and then we multiplied by 3. So that structure suggests that maybe the most efficient way of solving this is to first divide by 3 and then subtract the 2. And if you think about it, think about the number of steps this approach took. We divided by 3, that's 1 step. Then we subtracted 2, that's 2 steps. In this particular problem, we had to distribute first, that's 1 step. We subtracted, that's 2 steps. Then we divided, that's 3 steps. So I could make the argument that this is a slightly more efficient way of getting the solution, but they both work just fine. Let's get a little more practice in using that structure. So if we can recognize the structure of an expression, we can often solve the equation containing it faster and with less manipulation. Exercise number 2. Solve each of the following equations by reversing the order of operations on the left-hand side of the equation. Don't distribute. So again, don't get me wrong. If I was writing a test for all of you to take and I gave you one of these 3 equations and I just said solve it, I didn't give you any way of solving it, I just said solve it, then I would feel comfortable with you rewriting the left-hand sides using the distributive property. And I'd also be comfortable with you solving it the way we're going to do it right now. So let's do letter A together. Again, just analyzing the structure on the left-hand side, I've taken x and I've subtracted 5, and then I've multiplied the entire expression by 2. So to solve it without using the distributive property, the first thing I'm going to do is I'm going to divide both sides by 2. That's going to leave me with x minus 5 on this side. 14 divided by 2 is 7. And so I'm then going to add 5 to both sides on this side. And that's going to give me x equals 12. I would have gotten exactly the same answer if I had first used the distributive property to rewrite the left-hand side as 2x minus 10. All right? Would have gotten exactly the same answer, x equals 12. But it would have taken me that extra step of doing the distribution. All right, I'd like you to pause the video now and try the same technique on B and C, and then we'll revisit. All right, let's do it. So in this case, we've added 6, then multiplied by 5. So I'm going to start first by dividing both sides by 5. That gives me p plus 6 is equal to 20 divided by 5, which is 4. I'm now going to subtract 6 from both sides. Be careful here. 4 minus 6 is going to be a negative, and specifically, it's going to be negative 2. Okay? Likewise, letter C, right? We're subtracting 3 from y, then we're multiplying by negative 11. So we're going to undo that by first dividing by negative 11 and then adding 3. All right, so let's divide by negative 11. Okay, those cancel, leaving me with y minus 3 on the left-hand side. Be careful here. Positive 77 divided by negative 11 will be negative 7. Then I'm going to add 3 to both sides. All right, those two cancel. Negative 7 and positive 3 leave me with y equals negative 4. All right. Recognizing what has been done to the variable and the fact that we can undo what's been done to the variable makes these actually relatively quick to solve. But again, I'd like to emphasize, you could solve them by first distributing through by the multiplication and then, solving from then on out. Now let's look at some problems that also involve division. Okay, now division distributes just like multiplication does. We don't do it nearly as much, but it does. And we're going to look at that a little bit in exercise number 3. So let's take a look. Exercise number 3. Consider the equation n plus 4 divided by 2 equals 7. Letter A, show that n equals 10 is a solution to the equation. All right, well, let's do this together, okay? So what am I going to do? I'm just going to take my 10, plug it into the equation, as always, right? Then, of course, I've got to add the 10 to the 4 to get 14. Then I have to do the 14 divided by 2, and that'll give me 7. So you bet, n equals 10 is a solution. Now, just like what we did before, I want to list the steps in order that I use to evaluate the left-hand side of the equation. So, what did I do? Well, the first thing I did was I added 4. And again, I forgot the d. I added 4, and then the second thing I did was I divided by 2, right? I added 4, and then after that, I divided by 2. So that immediately tells me how I should go about solving the equation, right? If I first added 4, and then I divided by 2, then I should reverse that by multiplying by 2 and then subtracting 4. So let's see how that process works in letter C. All right, our equation is n plus 4 divided by 2 is equal to 7. All right, so the first thing I'm going to do now is multiply both sides by 2. And literally those two cancel, leaving me with n plus 4 is equal to 14. Now I'll subtract a 4, and I'll get n is equal to 10. Right, exactly what I knew back from letter A. Now, right, with division for a lot of students, it's not as obvious to them that they can distribute. Okay, and oftentimes when you distribute division, things get messy because fractions get involved. Multiplication is much nicer. When you take a whole number and multiply it by a whole number, you get a whole number. On the other hand, division, often when you divide one whole number by another, you don't get a whole number. In this case, you do. And let's take a look at that in letter D. Letter D says, solve the equation by distributing the division by 2 as a first step. All right, so let's take a look at this. In other words, right, I've got n plus 4 divided by 2 is equal to 7. I can literally distribute division the way I distribute multiplication, right? In other words, like if there was a 2 sitting outside of an n plus 4, I'd multiply the n by 2, then I'd multiply the 4 by 2. But now I have an n plus 4 all being divided by 2, so I divide the n by 2 and I divide the 4 by 2. Now thankfully, 4 divided by 2 is a relatively nice number, right? Not a relatively nice number, it's a very nice number, right? 4 divided by 2 is just 2. I like 2's in this problem, a lot apparently, right? And once I get it to this stage, right, now I can solve this like any other two-step equation. I can subtract 2 from both sides, right? Those will cancel. That'll give me n divided by 2 is equal to 5. So I multiply both sides by 2, and I get that n is equal to 10. But this is way, way more fraught with difficulty because, quite frankly, if there had been a 3 or a 9 or some odd number up here, then when I divided by 2, this would end up being kind of a not so nice fraction, certainly wouldn't be a whole number. Then I'd have to like subtract a fraction from 7. It'd be chaos, pure chaos. So most of the time, when we have kind of a structure like this, i.e. we have a division going on as our second step, it pretty much always makes sense to then undo that division first and then undo whatever like subtraction or addition is happening second. Let's take a look at some of these in the next set of problems. All right, here we go, exercise number 4. Solve each of the following equations by reversing the order of operations on the left-hand side of the equation, parentheses, don't distribute. Now, just for a moment, right, think about this one if we did distribute, right? We'd have x divided by 5 plus 14 divided by 5 is equal to 4. And that would be awfully ugly, primarily because 14/5 is not a nice number. It's like, I don't know, it's like, it's just not a nice number. It's 2 4/5. I had to think about what the mixed number version of it was. So instead of doing that, what I do is I look at the structure and I go, x has 14 added to it first, and then that result is divided by 5. So the first thing I'm going to do to solve this equation is I'm going to multiply both sides by 5 to undo that division by 5. Those cancel. I'm left with x plus 14 is equal to 20. I subtract 14 from both sides, and I get x is equal to 6. Right? So easy. We undo the division, then we undo that addition. I'd like you to pause the video now and work through letter B and letter C. All right, apparently I really like division by 5 in this problem. I could have put any number there, but 5, whatever. So I've got y, I've subtracted 3, then I've divided by 5. I'm going to undo it by multiplying by 5 and adding 3. All right, so let's do it. Let's do 5 times y minus 3 divided by 5 equals 3 times 5. Again, those undo each other. That leaves me with y minus 3 is equal to 15. Oh, I'm sorry, that was a negative 3. So that should be a negative 15. Then I'm going to add 3 to both sides. Be careful here, a negative 15 plus positive 3 is negative 12. All right. And likewise, in the last problem, n minus 7 divided by 3 is equal to 6. I'm going to undo the division by 3, then undo the subtraction by 7. So we'll do a little 3 times n minus 7 divided by 3 is equal to 6 times 3. Cancel those out. We're left with n minus 7 is equal to 18. Add 7 to both sides. Nothing really tricky here. And n will be 25. All right, so we recognize the structure. We look at the variable and we say, what has been done to it? And this is particularly useful in equations where the variable only shows up once. If the x, the y, the n, the z, the w, whatever, is just there once in the equation, then we should be able to look at it and go, this is what happened first, this is what happened second, this is what happened third, etc., and then undo each one of them in the opposite order. Remember from the last lesson, right? Socks and shoes. I put my socks on first, I put my shoes on second, right? When I want to undo that, I take my shoes off first, I take my socks off second. Let's now look at a couple of equations to end the lesson that look pretty scary, right? In fact, though, if we can recognize the structure, we can sometimes make very complicated equations look relatively easy to solve. Let's take a look at exercise number 5. Solve each of the following by reversing the order of operations on the left-hand side of the equation. All right, let's do letter A together, have you do letter B on your own. All right, let's take a look, right? X only shows up once. What's happening to it? Well, I'm multiplying it by 6, then I'm subtracting 7, and then I'm multiplying that result by 5. So, in order to solve or isolate x, I'm going to first divide by 5, then I'm going to add 7, and then I'm going to divide by 6. Again, I'm just literally one by one undoing what's happened to x in the opposite order. So, here we go. Let's do it. Let's divide both sides by 5. And that leaves me with 6x minus 7 is equal to 11. Now I'm going to add 7. That leaves me with 6x is equal to 18. And now I'm going to divide by 6. And that is going to give me x equals 3. All right, believe it or not, I just slipped a 3-step equation in on you. Right? There were 3 steps. I divided both sides by 5, I added 7 to both sides, then I divided both sides by 6. I really shouldn't even call this a 2-step equation. It really is a 3-step equation. But more than that, what it is it's looking at the variable, understanding what's been done to it, and undoing it. Pause the video now and see if you can do that to letter B. All right, so let's talk about letter B. What happened to the variable w? I multiply it by 2. I subtract 9, and then I divide by 3. And by the way, if that's ever confusing to you, what I would suggest doing is saying, well, look, if I took a value of w, if I said, hey, w is equal to 8, check to see if this is a solution, right? Well, what would you do? I'd take 8, I'd multiply it by 2, then I'd subtract 9, and then I'd divide all that by 3. Okay, great. So I'm going to undo it by first multiplying by 3. Again, I have to do it to both sides because I'm using the multiplication property of equality. That's going to give me 2w minus 9 is equal to 21. You bring this up a little bit. Now I have to undo that subtraction of 9 by adding 9 to both sides. That's going to give me 2w is equal to 30. And now I'm going to just divide both sides by 2. And that is going to give me w equals 15. Again, this technique works beautifully if the variable shows up once and only once in the equation. If it shows up more than once, then we really can't use this. We've got to do some combining like terms and other work in order to really get the variable to only be in the equation once, so we can then isolate it using these various operations. All right, let's wrap this up. So pretty much in every problem today, we had an equation where the variable x, y, z, w, n, whatever showed up once. We looked at the structure of the equation to understand exactly what was happening to the variable, so we could then use inverse or opposite operations in the opposite order to get that variable all by itself and solve for its value. We'll be using this more in the remainder of this unit when we start to solve word problems and a variety of other problems that we can use two-step equations to work with. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.